When you're drawing perspective, what you're doing is you're taking the three-dimensional world that's around you and interpreting it onto a two-dimensional space. So you're drawing what you see, which is 3 dimensions, and you're putting it onto a page, a piece of paper that is 2 dimensions, or onto a digital tool, a digital tablet, which is also 2 dimensions. So to create that illusion of depth, there are some depth cues that you can add to your imagery, and there's terminology to the techniques that go with perspective drawing. So the viewer, or spectator, we'll call it for this illustration, is who is looking at the image that you're trying to recreate. So they'll be standing on a ground plane, and with this ground plane, you're looking at lines. So if these lines are going back in space, if these lines are parallel, they'll go back in space, and parallel lines converge in infinity. So when you start to draw on your picture plane, your two-dimensional surface, you need to represent the convergence of the parallel lines. And that is picture plane. That is determined by the horizon line, the eye level line, and the distance from the viewer to the picture. So we have our station point, which is the eye level point of the viewer, and that's connected to the vanishing point, which is the eye level line, which is the point on the eye level line where your parallel lines will converge. Now, when you're creating your picture plane, it should be placed within your cone of vision. So this circle represents the range of vision of the human eye that is in focus. So you can see outside of your cone of vision, but it's distorted. So the human eye sees between a 50 and 60 millimeter lens. So when we draw it, we use 60 degrees to create the cone of vision. When you draw outside of the cone of vision, if your picture plane is wider than the cone of vision and you're drawing outside of that, your perspective lines and your imagery can look distorted, and it may look unnaturally distorted. So to make objects look natural in perspective, you need to keep your picture plane within your cone of vision. So let's just do a quick review of our terminology. So our viewer is the spectator in this imagery, and the eye line, the eye level, is the station point. That's the distance the viewer is from the picture plane. And the viewer is looking at the imagery through a cone of vision, and your picture plane is placed within that cone of vision. And where the station point meets the picture plane, that's where your vanishing point is. And this is a one-point perspective terminology, but it does still work for two-point perspective and other perspectives, because the vanishing points are always on the horizon line, which is also called your eye level. So your eye level, that's the line that comes across. That's your horizon line. It is not always where the sky meets the ground. And on your picture plane, you can have a ground line that's representing where the actual ground is in the imagery, which can be different from your horizon line. And this vanishing point is representing the infinity point for your parallel lines. So let's look at the different perspective types that you can draw. So we'll start with one-point perspective. And we have our horizon line or our eye level line. That's placed in here. And now we're going to create our station point, the distance our viewer is from the picture plane. So that's our station point right there. So when we know the station point, we can determine the focal length that we want to use. So just a quick description. So focal lengths are adjustable with a camera. The human eye sees within this range. So if we bring this down and we're looking at our 1.60 degree angle range, so that's 60 degrees, cone of vision, cone of vision. There we go. So here's our 60-degree angle of view that we're seeing. But you can have other focal lengths with a camera. So you can get really close in on something that's very far away. That would be your 135 to 200 millimeter lens. And then you can get a wide range of imagery from a distance, and that would be your 16 millimeter lens. So you can see that there are other focal lengths, and you can draw these into your drawing. You can put them into your drawing, and they will change the shapes of your objects and your spatial dimensions a little bit in the drawing. So if you're drawing for storyboards, you may want to know what camera is going to be used for the shot, and you can set up the perspective in your drawing to match that camera lens. But for most perspective drawing, you're drawing with a human eye perspective. So we can place our cone of vision here. So from the station point where the viewer is at a 60-degree angle, where the lines cross the eye level or horizon line, that's the range of your cone of vision. And then your picture plane is going to be drawn within this. Again, if you have your picture plane outside of your cone of vision, you can still draw and you will get some interesting effects, but you will get more distorted perspective. So on the horizon line or the eye level line, on the picture plane, where that meets coming directly from the station point is your vanishing point. So this is your vanishing point. Now when you draw this imagery on your page, you can use a digital protractor. So you can see this is just an image of a protractor, and it can scale up and down. It doesn't matter because the angles will still stay the same if it's larger or smaller. So if I edit this, if I scale this and I hold down the Shift key in Photoshop and I scale this up, I can still get a 60-degree range in here from the center. So from the center it's still 60 degrees, so it doesn't matter the size of your protractor. You can also rotate your protractor around, and we'll use that for vanishing points in two-point perspective. So it's good to have an image like this for your drawing techniques and to get your angles correct. When you're dealing with 90 degrees, certainly you can use a box, and when you want 45 degrees, you can cut that box diagonally to create those. But when you're looking for other angles, use a protractor so it's accurate. And now to draw a box with inside this space, we need our vanishing points. Well, our one point perspective has one vanishing point. There's our vanishing point. So we are going to draw our lines out from that vanishing point, and we will get our shapes. So remember, with 1 point perspective, all of your lines, your depth lines, converge back to a single vanishing point, but your horizontal lines and your vertical lines are straight. And that's what you're looking at, that's right in front of you. That's what you see. So you see in multi-point perspective. So what's right in front of you is 1 point. If something gets turned, or if you turn your head, it becomes 2 point perspective. So, but when you're drawing 1 point perspective, your depth lines converge back to the vanishing point, and your horizontals and verticals are straight. Now with 2 point perspective, it's the same idea, but this time the object that you were looking at in front of you has either rotated or the viewer's head has turned, which makes the verticals remain straight, but the horizontals are now converging to the left side and the right side. So we'll start again with our station point line. And to create our cone of vision and our picture plane. So this is also, here's our 60-degree cone of vision that we're going to use. But to create the vanishing points need to be at a 90-degree angle from each other. So if we turn our protractor, so this is, let's bring this up so we can see it a little bit clearer in opacity. So again, from the same station point, you need to have a 90-degree angle, and that's where you will place your vanishing points. You can, so it doesn't have to be exact where 45 degrees is right in the middle. You can rotate this so that one vanishing point is here and the other vanishing point is at a distance, so right from the center, so it's off center. You will get a different perspective when you do that, and that's fine. And there can be images that you want to distort one side of the perspective more than the other. So you can do that. But we want to have a 90-degree angle, and that's where we'll place vanishing point 1 and vanishing point 2. So now you're drawing the horizontals from the vanishing points, the left and the right side, but the verticals are staying the same. So if you're going to draw your guides, see if we can change this color. Here we go. So you can see that from vanishing point 1, the lines are converging, and vanishing point 2 they come to the other side, and where they meet, that is your vertical. So your horizontals are converging in space, and your verticals are coming back. So this is with the 60-degree cone of vision. You can also change the cone of vision in your two-dimensional drawing. So just for curiosity, if we look at an 84 degrees, so if we turn on our imagery, 84 degrees, which is a 16-millimeter lens, then that is your picture plane within your cone of vision. So you have more of the space that you're capturing. If you go to the other extreme and you go to a 12-degree focal length or 35mm lens, or even smaller, that is your picture plane within your cone of vision. So you can see that the space in here, you're really zooming in on your objects, and they are going to the same vanishing points. So the same line coming out of the points will look different. You'll get a different box for the different perspectives. So that is 2-point perspective. With 3-point perspective, you're dealing with the idea of looking above and looking below an object. So with 1-point perspective, the object is right in front of the viewer. With 2-point perspective, the object has turned or the viewer has turned. With 3-point perspective, the object is tilted up or tilted down, which means the horizontal lines and the vertical lines are now angled to the vanishing points at the same time. So there is no longer a straight horizontal or a straight vertical with 3-point perspective. And you have what's termed a bird's eye view or an ant's eye view. So you're either looking down on something or you're looking up on something. And when you are creating these 3-point perspectives, you need 3 vanishing points. You can kind of use the same measuring for it, but generally it's just a distance away. Vanishing point 3 is a distance away, and your picture plane is within the horizon line, the eye level, and vanishing point 3. So when you start to draw these guides, you can see every line is now connected to a vanishing point, and it's coming in at an angle. So the distance of your picture plane from your horizon line will determine the distortion that you see on the image. So this is a much more distorted shape because it's further away from the horizon line than this shape. So that's a bird's eye view. With an ant's eye view, you're going to have your horizon line at the bottom, and you still have the same picture planes. And it's the same idea. You're now drawing your horizontals from the side vanishing points, and your verticals are all converging to your third vanishing point. And again, the further away the picture plane is from the horizon line, the more distortion is in the shape. And 3-point perspective is a very useful tool when you're drawing comic books, when you're drawing storyboards. It gives a very interesting perspective, an interesting point of view on the imagery. So 1-point perspective, 2-point perspective, and 3-point perspective are your linear perspectives. That means the picture plane is flat. There is also curvilinear perspectives, and that's when you try to represent the curved space around you onto a 2-dimensional surface. So 4-point perspective is representing one of the axes as a curved space. 5-point perspective is representing both axes, your verticals and your horizontals, as curved space, and that creates a hemisphere. And 6-point perspective is the same idea as 5-point perspective, but you now have the back view, and together that creates a sphere. So that is the objective when you're drawing these curvilinear perspectives. And 4-point perspective has 1, 2, 3, 4 vanishing points. 5-point perspective has 1, 2, 3, 4, and 5 is the depth. And 6-point perspective has the vanishing point from behind the viewer. That's the concept of linear perspective and curvilinear perspective. That takes you from 1, 2, 3, and 4, 5, and 6 perspective. So curvilinear perspective and 4-point perspective requires a curved grid. And you can create that, so you can download it, or download one if you can find one online, or you can create it. So you want to draw a rectangle within a circle. And then you're going to create your grid on your square. So you have a square inside your circle. And if you just keep dividing the sections, so if you go half and half, that'll give you the center points, and then if you take those halves and keep dividing them, you will get all of your lines, and then you can create a grid within your square. Now what you want to do is you want to draw to the circle from the center point and go through each of these grid points. So basically what you're doing is you're attempting to create an evenly spaced curvilinear measurement. Yes, when you draw curvilinear space, you can certainly have curved space within these lines. But if you're looking to create a grid, this is a good way to do it. Then once you have those points, you can go from the points that are touching the circle, you can go and draw a line to the center line. And you'll get this. Bump, bump, bump. All the way from where the curve and the line met to the center point. Draw in, draw in, draw in for all of them. And that will give you tick marks on your center line. And these are the guides for where your ellipses will be. And you can also rotate this if you're trying to get the other axes, and together you'll get the sphere. So when you use the horizontal tick marks, you can get your vertical spherical guides. And you're just creating spheres that line up with the tick marks. You can see the tick marks underneath here. So that is your curvilinear grid now. For your 4-point perspective. So let's go look at our 4-point perspective here. So you want to place your 4 vanishing points at the north, south, east, and west of this sphere. So there's your 4 vanishing points. And 4-point perspective is drawn like 2-point perspective, but one of the axes has curved lines. So your setup is like a 2-point perspective. So usually it's the horizontal lines that are straight and the vertical lines that are curved. And that's your grid guide to determine how you're going to draw your shapes. So if we draw 4-point boxes, you can see that the vertical lines are straight and they're converging back to the 2 vanishing points, but the horizontal lines are curved and they're also converging back to the top and bottom vanishing points. What this does is this allows you to look up and down at the same time on an image. So with a 3-point perspective, and let's do a little. With 3-point perspective, you are attempting to draw from your points, your top and bottom, but when you get like this happening, so it's giving a hard edge to shapes that you're trying to cross over this center line space. So if this is a wall, it doesn't have a hard edge right in the center. So this space here and here doesn't work well or accurately in three-point perspective when you're trying to look at something from the distance where you can see top and bottom at the same time. So that's where four-point perspective comes into play. So four-point perspective is not three-point perspective with the top and bottom points. It is the viewpoint of three-point perspective, but is now taking into consideration the curvature of space. So five-point perspective, again, is the hemisphere that you're looking at, and you'll have your verticals and now your horizontals curved in space. So you want to create a grid, a curved grid space, using the technique for horizontal and vertical curved lines. And now you have a vanishing point in the center. So you have 1, 2, 3, 4, and 5 is the vanishing point in the center. So your depth lines are now going to go back to vanishing point 5. So five-point perspective is drawn like one-point perspective, where your depth lines are going all the way to one central point. But now, instead of your horizontals and vertical lines being straight on your objects, your horizontal lines and your vertical lines are curved on your objects. So you want to draw your verticals out from the center when you're drawing them. And this is how you'll create your shape. So for this demonstration, we're just using cubes, because basically any object can be fit within a cube. If you draw a cube, if you're not sure how to draw something, draw a cube and then break down that cube shape into other shapes and you can get your object. But we can see our converging lines are going to the central vanishing point 5, and then our horizontal lines are curved, so they're following the curved line, they're following the curved space, this curved grid, and our vertical lines are curved, they're following the curved space. They're following the curved space. So in five-point perspective, you're drawing your horizontals and your verticals in curved space, and your depth lines, your dimensional lines, like one-point perspective, back to vanishing point 5. Now, six-point perspective is five-point perspective in two sections. So if you think, if you're thinking of what it might seem like if you take a sphere and you cut it in half and then you open the two halves and line them next to each other, or if you crack a walnut in half and you just open it up and look at it and you see the two halves together, that's what you're doing with six-point perspective. So you have your curvilinear space of one hemisphere, and then your curvilinear space of the opposite hemisphere, and you can get your guides in here. So it's still back to the 6 point. It's like 5-point perspective with the 5th vanishing point in the center. The 6th vanishing point is the same point directly behind you. and then you can create your boxes. But here's the trick about 6-point perspective. Most of the time you see the grid drawn like this with the top and bottom. There are other ways where you can overlap it, and you'll see the curved space is kind of overlapping with different converging points. But when you're drawing it connected, just understand that this outer line matches on both of them. So this outer line is directly connected to this outer line. And since this is now flipped upside down, it's a little bit disoriented, but it's easy to understand. So this point is connected to this point on here. So if I take this sphere and if I rotate this, so if this is now rotated over here, this point would be connected to this point. So whatever's here is here. This is now coming in, so there would be a little bit of space, but that would be connected. So anything on the edge is connected. Again, if I take this sphere and I rotate it around, so it's over here, this point and this point are connected. And the object then continues on this side. It wouldn't always match in here. So depending on what your object is, one side within the spherical space will be different than the other side. It could be a couch or a chair or a picture or a window. So again, this is just a demonstration with cubes. So this part and this part could be different, but this part and this part will match. The same thing on the other side. So anything on the edge is going to match when it gets lined up. And then what's within it is the different spaces. So this is the hemisphere directly in front of you, and this is the hemisphere directly behind you. So the objects that are behind you are different than the objects that are in front of you. But because we've separated out the space, that's what the separation looks like. So that is perspective. That's how you draw perspective. Those are the concepts of perspective and what you're looking at and what you're trying to recreate when you're drawing dimensional space on a flat plane.